factoring of squares and cubes. So the first thing we want to do is essentially establish when we can factor things that are squares and things that are cubes. So in order to tell if something is a square, we're looking for values that can be square rooted. Things that are cubed, we're looking for things that could be by the root of 3, taken apart by the root of 3 with whole number values. We could technically do it and get decimal values, but we're not interested in that. We're looking for what they call like natural numbers, so like 1, 2, 3, and 4. So the very first one, look at 9. So I'm going to start with squares. I can find the square root of 9x squared. I can find the square root of 49. That works out. But for squares, there's only one type that actually works, and it's called a difference of squares. Oh, that was slow. It's called, that's why. So like we said, it's only with a difference that we can do this, and because this is not subtraction, it's addition, there's no special way of factoring this. So this is kind of how it is. There's nothing we do with this. Okay? In example 2, obviously we can square root it. We've already established all that information, and this is a subtraction sign. So we can find what's called a difference of squares here. So the very fast way to do this, okay, is essentially to set up 2 brackets. Okay? You find the square root of the first term, and you find the square root of the last term. We neglect that negative sign because we can't find square roots of negative values. Okay, we're just looking for the absolute value. So square root of 9 is 3, okay? And square root of x squared is x. So we have 3x. So that becomes the first term in each bracket. Write those ones in red. Okay, and then we'll do this in green. Square root of 49. The square root of 49 is 7. So that becomes the second term in each bracket. So the brackets hold what are called binomials. That means there's just 2 terms in the brackets. Okay. And then we just put an addition and a subtraction sign in each of them. It doesn't matter if it's the addition first or it's the subtraction second. But that's it. That's the very, very, very fast way of doing this. There is another way of doing it where we add a term to the middle, and maybe I'll do that at the end. But let's just go through the shortcuts, and then I can show you the, I don't know if it's called the proper way, but the long way of doing it. Okay? So let's go down to our next examples here. I left a lot of space. Okay, square root. Square root of 27 is going to be some decimal value, 5 point something, something, something. That's not going to work out. So we're not using square roots. Let's use cubed roots. Can I find the cubed root of 27? I know that I can. The cubed root of 27 is the value of 3. And the cubed root of x cubed is just x. So that works out really nice. And the cubed root, disappear on me, of 8 is 2. Perfect. So this checks out. This is something I can use cubes for. And you can do a sum and a difference of cubes. So both of these are factorable with our little shortcut. What we should do is write out a rule for them. And you know what? I should have wrote out a rule here. I'll write one out after at the end. So our rule here is if we have a cubed plus b cubed, how can it be simplified? Well, we can write it as a plus b times a squared plus a times b plus b squared. So here's our little rule. Well, I'll try to color code it here. Here are a's. These are my a terms. That's squared. They probably used x and y in your example there.
Yeah, they did. Yeah. But not my example here. It says negative.
Oh, you're right. Sorry, I wrote the negative in the wrong spot. Very good. Equals plus minus plus. Yes, very good. Okay, so how is this all broken down? Okay, what's actually happening is we're finding a number of cubed roots and then squaring things. But if we can just always find the base value, just what the a is, so the cubed root of everything, we can kind of just plug them in. Because there's all of these a's, and then we can plug in our squares after if we're unsure how this all really builds, okay? So like I said, let's find the cubed root of our first term. So the cubed root of 27x to the power of 3 is just going to be 3x, okay? And the cubed root of 8 is just going to be the number 2. I'll write that in blue. That will be our b term. So here's our a, here's our b. So when we go to write them in, well, here we're just looking for a, which is 3x in this case, so that works out really nicely. Over here, the next term, b, is just a value of 2. So that one's really simple to set up. It gets a little harder here. They're looking for a squared. Okay, it'll be easiest if I actually just write this in a set of brackets. I'm replacing just a with 3x, and then I'm going to square it after. Okay, then we subtract a again. Well, a is again 3x. So the second bracket's a little more complex. I'm going to put brackets around it. The reason I didn't put brackets in this one is because they wouldn't have made any difference. There's no multiplying or anything with it. The brackets just eventually would have dropped off, which we're about to do there. Okay? So let's get back to this one. This is 3x times b. Well, b is the number 2, so I'm going to put brackets again. And the reason I put in brackets is because they're multiplied times each other. Okay? And plus, in our last one, we'll put 2. And this 2 is technically to the power of 2. Okay, so there's a couple extra steps we have to do for our sum of cubes. This still stays. Let's get some room here. 3x plus 2, that's done. 3x squared, well, that's 3 times 3, which is 9. Okay. And x squared is x squared. Think of this like subtract 3x times 2. Well, that becomes 6x. Yeah, so we have minus 6x. And then 2 to the power of 2 is 4, so plus 4. And there's your sum of cubes. So we've kind of established that one. Okay. I'm going to move it over a little. I know you can't do this on paper. Give myself room over here. Now in this one, the only difference is this is a difference of cubes. So I'm going to write the difference of cubed rule, and we're going to probably just kind of jump right to the end since you've already gone through this process here. The difference of cubes, I'll write them out again, is a cubed subtract b cubed is equal to a minus b, and then all addition in the other bracket values the exact same. So we have a squared plus a times b, so write ab, and then plus b squared at the end. Okay. So you can go through the same process like we did. We find the cubed root of the first one. That's just going to be 3x. Find the cubed root. Again, not the negative, just the absolute value, the 2. And we kind of go about replacing the a's with the 3x here. And don't forget, we'd have to square it. We replace the b's with the number 2. And don't forget, again, we'd have to square it. But since this is the exact same question, the terms are all going to be the exact same. And the only difference is this operation and this operation are going to be reversed. So we can go right to the final answer here. The final answer is, and I'm not going to write the operations in, I'm just going to write the terms this are. So 3x, 2, 9x squared, 6x, and 4. So I just wrote the absolute values. And let's look at what we have here. We have a negative, a positive, and a positive. So that's how I write these in. A negative, positive, and positive. And that's now a difference of cubes. And that's it, okay? And for difference of squares, I suppose I should have given you a little rule here. If we call this a, so a squared minus b squared. Okay? And what it's written as now is a is the first term in each, b is the second term in each, and you just have a plus and a minus. Okay? So again, the first steps, recognize if it's a sum of squares, there's nothing we can do. Difference of squares, we can do stuff. Sum of cubes, we can do stuff. Difference of cubes, we can do stuff.